In this next section, we're still talking about linear models, and we're going to build linear functions from data, from a table of data. So you can see here that we have a table of data that relates the relative humidity, which is our X column right here, and the apparent temperature, which is our Y column. This gives us ordered pairs, like you see on the far right. But it's the table part of this that we're going to enter into the calculator. You can sketch a scatter plot by hand, but it's much more effective and much easier to plot it in the calculator. So we're going to do that together. First thing you want to do is make sure that you have a new document. So enter 1. And if you had another document saved in there, just tab over to No and don't save that document. We want to go to Add Lists and Spreadsheets to put this table in. So we're going to press 4 and then up arrow to get to the row where the titles go. I could type relative humidity in there, but I just want to go with the simple version. So I'm going to type X for my label on the first column, and then in the second column I'm going to type Y. The gray row that you see in the middle here, the second row, is a formula row, and we're not going to use that. We're just going to enter our data below. You can make sure that you click in that first cell, and then if you press enter from row to row, then you can easily input your X values and then come back and put in your Y values the same way. So now you see that I have the X column and the Y column entered. So I've got my list and spreadsheet, and now I want to add a page. So Control Doc adds a page, and I want a data and statistics page. So I press number 5. So here are all my points that I just entered into my list. I want to arrange these so that the X values of the points are on the horizontal axis. So you click in this area to add a variable. You just use your click pad to move around, and then I want to select the X. If you arrow over, and you can just slide your finger over the click pad to get your cursor in this area right here, and click there, and I want the vertical axis to be Y. Notice that my points arrange themselves according to ordered pairs, where if I'm at 0, then this value is 64. If I go to 10, this value is 65, and those are the same points that I had in the table. So the question is, what happens to the apparent temperature as the relative humidity increases? You can see as the relative humidity, which is X, increases, that the apparent temperature is also increasing. And it appears to be linear. It's a little bit bumpy in the middle, but it does appear to be linear. Your scatter plot will look different based on how many points you have available to you, the accuracy of your typing, and just the accuracy of the data itself. You can see that both of these scatter plots on the screen represent linear data. So even though they don't form one line, in general, all the points taken together resemble a line, either with a positive slope, as we see in example A, or a negative slope, as you see in example B. There are other scatter plots, other tables that you can get that are clearly not linear. This one looks more parabolic, parabola opening down perhaps, or part of a cubic. And then this one has yet another shape. This is probably a cubic, but definitely nonlinear. This is nonlinear as there's an obvious curve right there. Now you could fit a line to it, but just looking at the data, it's pretty clear that a line is not the best fit there. Take a minute to tell whether the relationship between the two variables is linear or nonlinear. So if you're looking at example A, do these dots resemble a line? And yes, they do. So this is a linear data table. These dots look more like a parabola, so I hope you said nonlinear there. Going back to our table of linear data, we can find a model for this linear data by choosing any two points, any two data points, and writing the equation of the line. So the first thing you need to do is find the slope of the line. So if these are the 2 points that you chose, then you would subtract the y value, 74 minus 65, which simplifies to 9. Subtract your x values, 80 minus 10, which gives you 70. So this is the slope of your line. You want to put that slope into the point slope formula where 9 over 70, your slope goes right here for m, and choose either one of these points for your x1 and your y1. When you substitute, they use this second point right here. When you substitute that in, you get this, and when you simplify, this is the line that you get. So we'd like to see how closely this line fits our data. So we want to go to the calculator and put that line on top of our data and see what happens. So one way to do that is, once you have your scatter plot up, is to press menu. And then we want to, I believe it's under 3, actions. No, it's under 4, analyze. We want to plot the function. So we're going to choose option 4. Notice it gives us a window to enter our function there. When you press enter, it sketches that line in there, and that seems to be a pretty good fit for our line. If we had chosen 2 other points, we would probably get a different line, but it would fit the points rather closely because this data is very closely linear. There is a line of best fit that your calculator has an algorithm for, to find a very specific line that fits this data in the very best way. It's called the line of best fit. We're not going to go into how that line is developed. We're just going to let the calculator figure it for us. So if we have our scatter plot up there, I'm going to go ahead and erase the line that we had. Well, maybe I'll leave it there so that we can compare. If you press menu and go back to analyze, which is number 4, then we'll go to regression, which is number 6. And we're looking for the linear regression. Now you can either do mx plus b, which is what we're usually using, or they have an a plus bx. Let's do the mx plus b since we're more familiar with that. Now you see this bold line and you see this new equation. This is the line of best fit. It's not exactly the line that we had drawn, but it's pretty close to that line. So that equation of the line comes from this information on the linear regression. Again, they're using a instead of m for the slope, but the slope is 0.1209. That means that the apparent temperature rises 0.1209 degrees for every 1% increase in relative humidity. Remember, that's rise over run. But instead of counting our relative humidity by tens, we're counting our relative humidity by 1. We can use our line of best fit to predict the temperature when the actual temperature is 72 degrees and the relative humidity is 45%. In order to do that, remember your x is your horizontal axis right here, and that's the relative humidity. So we can put in 45 for our relative humidity for x and compute that in our line of best fit, and we get approximately 69.8 degrees Fahrenheit. You can also use the same line of best fit to predict numbers outside of our view window right now. So we might want to do 120 or 180. As long as we stay fairly close to the data that we have, then it will provide a good estimate.